Welcome back, and I hope you had a great Thanksgiving holiday. Um, we'll go ahead and continue with integration by parts. Okay, so let's take a look at the formula for integration by parts. So we'll start with taking the derivative of the chain rule. So let's say we take the derivative with respect to x of u times v. Then we end up with u times v prime plus v times u prime. Sorry, not the chain rule, but the product rule. So u times v prime plus v times u prime. Now, if we were to take the integral of both sides there, we'd have the integral of d dx u times v. That's equal to the integral of u times v prime plus v times u prime. And then we are taking the derivative, both of these, with respect to x. So dx here, and we'll go ahead and place a dx there. Okay. So we can pull this d dx outside. So that's d dx times the integral of u times v dx. And that's equal to, and now we're going to go ahead and split these two up. So that's the integral of u times v prime dx plus the integral of v times u prime dx. Okay. Now we need to remember that this v prime and u prime, well, we took the derivative with respect to x. So all v prime is dv dx. So this is equal to the integral of u times dv dx times dx plus the integral of v times du dx times dx. And this dx and that dx, this dx and that dx, they go away. Now the derivative of the integral here with respect to x, well, these two are inverses of each other. So all we're going to get here is uv. So now we have uv is equal to the integral of u dv plus the integral of v du. And with a little bit of algebra, we get the integral of u dv is equal to uv minus the integral of v du. And that's the formula that we went over before we went on break for integration by parts. So the integral of u dv is equal to uv minus the integral of v du. Also, just keep in mind that if we are taking this integral, and it's a definite integral, the integral from a to b of u dv, that's equal to uv evaluated from a to b minus the integral from a to b of v du. Okay. Now, when do we use integration by parts? So Okay, so we will use it whenever we're integrating an expression that involves different types of functions. So that's when integrating an expression that involves different types of functions. Okay. And we had an acronym before we left about the order in which we choose or use. So LIATE, so logarithmic, inverse trig, algebraic, trigonometric, and finally exponential. So this is the order for choosing U. So let's take a look at an example. Let's say we're going to take the integral from 0 to 1 of arc sine of x dx. Now when we take a look at this one, looks like we only have the one function there. Okay, but remember LIATE. So logarithmic, inverse trig, algebraic, trigonometric, exponential. So we do have an inverse trig. So we're going to let u equal arc sine of x. Then whatever is left over, that's your dv. So the only thing we have left over is the dx. So that's going to be our dv. Okay. So if u is arc sine of x, then du is equal 1 over the square root of 1 minus x squared dx. And if dv is dx, then the antiderivative of dx is just x. So v is equal to x. Okay. So the integral of 0 to 1 of u times v, of u dv is equal uv, evaluated at 1 and 0, minus the integral from 0 to 1 of v du. So now we substitute in our values here. So this is going to be u times v, so that's x arc sine of x evaluated at 1 and 0, 0 to 1, minus the integral from 0 to 1 of v du. Well, v is x, and du is 1 over square root of 1 minus x squared dx. Okay. So this second part here is just going to be, basically it's x over the square root of 1 minus x squared. It's a u substitution. So we're going to let u equal to 1 minus x squared, which is a problem that we've done before. And then du is negative 2x dx, and then we can compensate for the dx there. So here, this part here, we said we're going to let u equal 1 minus x squared, then du is negative 2x dx. So negative 1/2 du is x dx. So we're going to replace this x dx with negative 1/2 du. So we end up with x arc sine of x evaluated from 0 to 1. So we have minus and then a negative 1/2. So that'll be plus 1/2 times the integral from 0 to 1 of u to the negative 1/2 du. And taking our antiderivative, this part right here is going to be 1/2 times, well, this is u to the negative 1/2 plus 1, so it'll be over negative 1/2 plus 1, so that would be 2 over 1 times u to the 1/2. And back substituting in, we're just going to get u to the 1/2. So we have x arc sine of x evaluated at 0 and 1 plus square root of 1 minus x squared evaluated at from 0 to 1. Okay, substituting in our value, so that's 1 times arc sine of 1 minus 0 times arc sine of 0 plus, then we get the square root of 1 minus 1 minus the square root of 1 minus 0. Okay, so arc sine of 1 is pi over 2, so 1 times pi over 2, so that's going to be pi over 2. 0 times anything is 0, so it's pi over 2 plus, and then we get square root of 1 minus 1, square root of 0 minus 1, that's negative 1. So our answer is pi over 2 minus 1. Okay, your homework right before we went on break was section 8.2, 1 through 36. Let's take a look at number 35. So that one is the integral of e to the 2x times sine of x dx. So remembering our Liate, we have an exponential and we have a trig. So trig comes before exponential, so our u is equal sine of x. And our dv is e to the 2x. So if u is sine of x, then du is cosine of x dx. And if dv is e to the 2x, then the antiderivative of that, our v, is going to be 1/2 e to the 2x. So the integral of e to the 2x times sine of x dx is going to be uv. So it's u times v, so that'll be 1/2 e to the 2x times sine of x minus the integral of v du. So it'll be minus 1/2, I'll bring the 1/2 on the outside, e to the 2x times cosine of x dx. Okay, now if you look closely here, this second part here looks like we're going to have to do another integration by parts, because we're still in a situation where we have two different types of functions. Okay. So for this one, so now just looking at this part right here, remembering that we still have this, but just focusing here. So now we're going to let u equal cosine x. dv is going to equal to e to the dv is going to equal to e to the 2x dx. So du, the derivative of cosine of x, is negative sine x dx, and v is going to equal to 1/2 e to the 2x. Okay. Alright, so now our answer becomes the integral from e to the 2x sine of x dx is equal to this 1/2 e to the 2x sine of x minus 1/2, and now times this part right here, which is the uv. So it'll be uv, so that'll be 1/2 e to the 2x cosine of x minus the integral of v du. So that'll be, bring the 1/2 on the outside, so that's 1/2 the integral of v du. So it's actually minus du is a negative sine of x, so that'll make that a positive. And so that's e to the 2x sine of x dx. Okay. Alright, so distributing this negative 1/2 here, we end up with the integral of e to the 2x sine of x dx is equal to 1/2 e to the 2x sine x minus 1/4 e to the 2x cosine of x minus 1/4 the integral from e to the 2x sine of x dx. Okay. Alright, now we are in the same boat again, because we still have an integral to different types of functions that we would have to use integration by parts. Well, if we take a closer look here, we will see that our initial problem was taking the integral of e to the 2x sine of x dx. And notice over here, you have an integral of e to the 2x sine of x dx. So we're actually going to use a little bit of algebra here to solve this. So if we add 1/4 the integral of e to the 2x sine of x dx to both sides, we end up with 5/4 times the integral of e to the 2x sine of x dx, and that's equal to 1/2 e to the 2x sine of x minus 1/4 e to the 2x cosine of x. Okay. Now all we have to do is get rid of that 5/4. So if we multiply both sides by 4/5, then we're able to solve. So we're going to multiply both sides of the equation by 4/5, and then our final answer will be the integral of e to the 2x sine of x dx is equal to 4/10 e to the 2x sine of x minus, let's see, 4/5 times 1/4 is 1/5 e to the 2x cosine of x. And actually this one right here, this 4/5, we can just rewrite this as 2/5. But that's our answer. Okay, so that one was a little tricky. Okay, let's take a look at another example. Alright, let's take a look at another example. Let's take the integral of x squared times sine of x dx. So here, because algebra comes before trig, we're going to let u equal x squared. dv is sine of x dx. Du is 2x dx. And v, the integral of sine of x, is negative cosine of x. Okay, so we end up with uv, so it's going to be negative x squared cosine of x minus the integral of v du. So because that is a negative cosine of x, make that a positive. So we end up with v du, so that's 2x cosine of x dx. Okay. So here at this point, we need to use the integration by parts again. So this time, our u is going to be 2x, dv is cosine of x dx, du is 2 dx, and our v is sine of x. Okay. So the integral of x squared sine of x dx is equal to the negative x squared cosine of x plus our new uv, so that's going to be 2x sine of x minus the integral of v du. So v du is going to be minus 2 times the integral of sine of x dx. So that's negative x squared cosine of x plus 2x sine of x, and the integral of sine of x is negative cosine of x. So then that's plus 2 cosine of x and then plus c. So that's our answer there. Okay. And the reason I brought up this example is I wanted to show you another method for evaluating certain types of integrals, which is called the tabular method. And the tabular method works best on integrals of the form of x to the n sine of ax dx, or x to the n cosine of ax dx, or x to the n times e to the ax dx. And in each of these cases, you're going to let u equal x to the n. So the way it works, and we'll go ahead and take a look at this last example we did. Okay, the way it works is you're going to use a tabular 3-column method. And your 3 columns consist of an alternate signs, u and its derivatives, and v prime and its antiderivatives. Now what's key here is that u will eventually, by taking its derivative, you'll eventually get to 0. So with the last example we just did, we had the integral of, I think it was x squared sine of x. Okay. So here we're going to start with the positive. Our x squared is positive. So we have x squared. And here our v prime, or this is dx. dv dx is sine of x. Okay. Now we're going to always alternate signs with each of our rows here. So because we started off positive, this becomes negative. The derivative of x squared is 2x. The antiderivative of sine of x is negative cosine of x. Okay, we're going to keep going into our u, taking the derivative of u equals 0. So here, we go positive, negative, positive. The derivative of 2x is 2. The antiderivative of negative cosine of x is negative sine x. Okay. Then we go negative. Okay, the derivative of 2 is 0. And the antiderivative of negative sine of x is cosine of x. Okay. Alright. Now the way this works is you're going to go across and then down. Okay, across and down, across, then down. Okay, and then we don't worry about the 0 over there. So with that problem that we just did, here's our answer. The integral of x squared sine of x dx is equal to, so we're going to go across, so it's positive times x squared times negative cosine. So that's negative x squared cosine of x, then we go to our second row. Negative times 2x, it's negative 2x, times negative sine of x, so negative times negative is a positive, so that's plus 2x sine of x. Positive times 2 is positive 2, times cosine of that, positive cosine of x is positive 2 cosine of x. So that is plus 2 cosine of x and plus c. And then if you take a look at the answer that we just did without tabular method, you'll see that this is exactly that answer. Okay. So tabular method again works well with integrals of the form of x to the n sine of ax, x to the n cosine of ax, x to the n e to the ax. Okay. So your homework is on the chart. The homework though for today, I'm going to make them all odd. So take a look at your assignment log and it'll just be the odd problems. Alright. And I will see you in a couple of days.